In this lecture, we're going to solve this one by one. Let's take the first problem. We have a polynomial in the numerator and also a polynomial in the denominator. The polynomial in the numerator having the power of 2 and the polynomial in the denominator having the power of 1. Okay, so mainly we will use the division rule here also. So let's divide the polynomial x squared plus 3 by x plus 1. Now, in order to match the x squared, we need to multiply this polynomial x plus 1 with x. So we write x in the quotient. By writing x, we need to also multiply this x with 1. And we need to subtract the x squared plus x from x squared plus 3. We can cancel out x squared from both of them, and also we will left with the remainder of 3 minus x. We need to divide 3 minus x, which is the remainder now, by x plus 1. So mainly we have to multiply the x plus 1 with minus 1, because we have a minus sign here and we have a plus sign here. And if I write minus 1 in the quotient, I can place x plus 1 just below 3 minus x, placing the negative sign in front of it. Now subtracting minus x minus 1 from 3 minus x, I can cancel out minus x from both of them, and I will be left with 4 as a remainder. So we can write x squared plus 3 divided by x plus 1 as, you can substitute the value of x squared plus 3 x plus 1 equals to x minus 1 plus 4. You can substitute the value of x squared plus 3 divided by x plus 1 in the main equation. It will become, can you solve the integral? Why not? Take each term and try to integrate it. For example, in this case, the first term would be x squared plus by 2. Next is minus x. The next one, take the constant out, and we are remaining with the 1 upon x plus 1. It will be ln x plus 1 in the modulus operator. Lastly, add a constant. This is our final answer. Let's take another problem. In this problem, we have x in the numerator, and in the denominator we have x plus 3 and x plus 2. It can be combined, given to you, or you have to extract the roots of the polynomial. So anyhow, in such case, we need to do the partial fractions. What are partial fractions? So you need to convert this equation or sum of product into separate terms. For example, in this case, we need the x plus 3 in one side of the plus sign and x plus 2 in the other side of the plus sign. So I should write a blank with a division operation, with having a x plus 3 in the denominator and also this x plus 2 in the denominator in the other side. So how to fill this blank space in the numerator for the both? So here, first take the x plus 3 and equate it to 0. So we will have x equals to minus 3. Now put this minus 3 in the whole equation except x plus 3. After solving this, you will get 3. So place this 3 here. Now take this x plus 2 and equate it to 0. Now we need to place this x equals to minus 2 in the main equation except the x plus 2. So we get x by x plus 3. Now putting here minus 2 in the place of x, you get minus 2 as a whole. So place this minus 2 here. I'm placing the minus here. So you can convert the main equation into partial form and you can integrate each term separately. So the answer to this problem is, okay, now this is the final answer. This was the easy way of solving such problems. Let's go through another method of solving such problems, which is completing the square method in the denominator. You can write the main equation as this, x by x squared plus 5x plus 6. Now you need to multiply 2 in the numerator and also divide by 2. 5 by 2 as a whole, and take this plus 6 to the right and add 5 by 2 whole square and also subtract 5 by 2 whole square in the middle. Okay, so now we need to take the first 3 terms and combine them all, and you can solve this part as, we can use the substitution method by substituting u equals to x plus 5 by 2. Now differentiating both the sides, we get, I can replace this two equations of u and dx in the following main equation, and it will look like, and also you can change x as u minus 5 by 2. Now you're going to distribute this denominator to u and minus 5 by 2. For the first integral, you can substitute t equals to u square minus half whole square. After differentiating both the sides, you get dt equals to 2u du. So the final answer to this first integral is, now let's talk about the second integral. Now you can write the denominator as, so by partial fraction you can write the second integral as, I can integrate each term of the second integral separately. Okay, the final answer to this problem is, now you have to substitute the value of u as x plus 5 by 2 in the original equation. Now after you get this one, okay, so you can also evaluate this integral. Also you may evaluate this expression as, okay, now you can take this 2 out as a common. Okay, I'm not changing the constant because it is a constant, so do not worry about this constant. So if you take common as a 2 from the constant, it will remain a constant, so I'm not changing the sign of the constant. Okay, now I'm taking this 5 inside of this ln. Now I am combining this ln terms as a whole. Okay, so we can write the numerator as, now you can cancel out the u minus half from both the numerator and denominator, and also you can so the power of u plus half will be incremented by 1 because of this 5, and it will add up to 1, so it will be totally in 6. Okay, lastly, if you take this half into the ln inside, so it will cancel out this 6 as 3 and 4 as 2. Now you can replace the u with x plus 5 by 2, and you can add a constant. So the last answer that should match with the previous integral result, which is the same we have done in the process, so it will be, okay, so both the results got matched. So mainly, if the polynomial having a degree equal in the numerator as well as denominator, you have to use the division rule, and if you have the roots like this, x plus 3 and x plus 2 as a polynomial, you can either use the partial fraction method, or you can use the completing the square method to solve such problems. So I hope you have enjoyed this tutorial as well. You have got the knowledge of how you can solve the integral as quickly as possible. So make sure that you subscribe my channel and also click the bell icon so that you can be notified every time when I upload a new video. So thank you for watching.